Hello everyone, welcome to Demystify Maths. We begin today with Chapter 1, Real Numbers of Class 10th. It is according to the reduced syllabus for March 2021. So go grab your registers, and before that, have you hit the subscribe button? Press the bell button as well. Fundamental theorem of arithmetic. Let's straight away start. What does this theorem state? Fundamental theorem of arithmetic states that every composite number can be expressed as product of its prime factors. You have done prime factorization in earlier classes also. Like I can write 6 as 2 into 3. I can write 15 as 5 into 3. Now, what is special in fundamental theorem of arithmetic after this expression is, number one, that the expression is unique. Second, order of prime does not affect. The order of prime factors does not matter. Right? So what is fundamental theorem of arithmetic? Repeat. Every composite number can be expressed as a product of the prime factors where the expression is unique and the order of the prime factors really does not matter. Let's start a question. Let's apply the theorem to the questions. We are not doing exercise 1.1 because Euclid's lemma is not a part of the syllabus for 2021. Exercise 1.2, question number 1, express each number as a product of its prime factors. So 140, you have learned prime factorization in your earlier classes. So 140, if I prime factorize, it is 270, 235, 35. And then 5 sevens are. So now 140 can be written as 2 into 2 into 5 into 7. So the given number, a composite number, is expressed as a product of the primes. So you're done. Let's do the second part now. Second part, 156. So let's start the factorization again. So it is 278, then 239, and then 313. So again 156 can be written as 2 into 2 into 3 into 13. Done. So the composite number expressed as the product of the prime, which expression is unique, but the order of the primes does not matter. Like I could have written 13 into 3 also. Let's take the third part, 3825. So it's not divisible by 2. So I'll begin with 3 because it's divisible by 3. If you add them all up, the sum is divisible by 3. So 1, 2, 7 and 5. Then again by 3, 4, 2 and 5. Now it's not divisible by 3 anymore. So I will pick 5. So 5, 8 and 5. And then again 5, 17. Right, so now 3825 can be written as 3 into 3 into 5 into 5 into 17. So you have expressed the given number as product of the primes. Let's do the fourth part now, 5005. So I'll start the factorization by 5 now, 51001. Now 1001 is divisible by 11. 11 nines and then ones are. 91 is divisible by 7. So this is 7, 1 and 17. So 5005 can be written as 5 into 11 into 7 into 17, the product of the primes. Moving on to the last part, 7429. Now this is not divisible by 2, 3 or 9, rather 11, not even 13. This is divisible by 17. So when you divide 7429 by 17, you get 437, right? And now 437 seems difficult to divide, but it is very much divisible by 19. And this is 19 into 23. So 7429 is 17 into 19 into 23. Done. Let's move to the next concept of HCF and LCM. This also is a quick revision of what you have done in earlier classes. Let's revise it with the help of a question only. Exercise 1.2, question 2, first part. We have to find the HCF and LCM of 26 and 91. So first, let's prime factorize. 26 we know is 213. That's it. 91 is divisible by 7, 7 and 13. So how do you find the HCF? What does HCF means? Highest common factor, right? So here if I write 26 as 13 into 2 and I write 91 as 13 into 7 and I find the product of all the common factors, which is only 13 here, HCF is 13. Let's find the LCM now. 26 and 91. So the common, I can start with 13, 13 twos are, and 13 sevens are, and that's it. So LCM will be 13 into 2 into 7. So 13 into 14, which is equals to 182. So we have found the LCM and HCF, but there is an important property here that LCM multiplied by HCF is equals to product of the two numbers. And we have to verify this. Verification means we'll solve LHS separately, RHS separately, and then see whether they are equal or not. So let's first find LCM into HCF. So that will be 13 into 182. So when you multiply it, you get 2366. Now let's find the product of the two numbers. And what are the two numbers which are given in the question? 26 and 91. So product of the two numbers will be 26 into 91, which is also 2366. Hence verified. The second part of the same question now, 510 and 92. So first let's factorize them. 510. I can start the factorization by 2, 3, 5, but it has to be a prime number because remember the occurrence does not matter. So 5, I'll begin with 5, and then I'll come to 2, 2, 5, 51, and then 3, 17. Then 92. Let's do 92 now. Again 2 4s are, and then 6 are, and then 223. So we know 23 is a prime number, so prime factorization stops there. Then let's find the common factor. 510, it is 5 into 2 into 3, and 92 is 2 into 2 into 23, and the only common factor is 2. So we have reached HCF, which is 2. Now let's move on to LCM. So 510 and 92. Since we know the only common factor is 2, so it is 2 twos are, and then 5, and then 5, and then 46 are. This is one way, or you could have multiplied all these factors here where 2 was written only once. You could have chosen any which way. LCM will be 2 into 255 into 46 because they are prime, co-prime. So it is 23460. Now let's find the product of HCF and LCM and product of the two numbers. So HCF multiplied by LCM, that is 2 into 23460. That will be 46920. Now let's find the product of the two given numbers. So product of two numbers will be 510 into 92, right, which is also 46920. So hence verified. Done. Let's move on to the third part now. Moving on to the third part of the same question, 336. So I'll do it with 3, 3, 1, 1, 2, and then I'll have to switch over to 2 because it's not divisible by 3. 2 5s are and 6, and then continuing to 28 to 14 to 7, and then 54. You may even write it down as 7 into 1 if you want to. Then 54, I'll divide by 3 first. So 3 1s are and 8, and then 3 6s are, and then 3 2s are. Right? So first let's find the HCF. For HCF, I'll find the common factor. So 336 is actually written as 3 into, then there are 4 times 2 into 2 into 2 into 2 into 7, and then 54 is 3 into 3 into 3 into 2. So again, the common factor is only 2 here and 3 here. Right? So HCF becomes the product of these two, that is 6 is the HCF. Now let's find the LCM. How do we find the LCM? We multiply all these factors, both of them, but the common one written only once. So it is 3 into 2 into 2 into 2 into 2 into 7. Now I will not write this 3 because it's already taken there, into 3 into 3, and I will not even take this 2 because it was common. So when you multiply all of it, you will get 3024. Now we have to verify also. Let's do the verification. For verification, HCF into LCM, that is 3024 multiplied by 6. This is equals to 18144, and when we take the product of 336 and 54, that is also 18144. This question is complete. Question number 3 now. Find the HCF and LCM of the following integers by applying the prime factorization method. This time let's write a little straight away. 12 we know is 4 3s are, and 4 is 2 into 2 into 3. Right? Then it is 15. 15 we know is just 5 3s are, and then we know 21 is 7 3s are or 3 7s are, anything. Now for HCF, we can see that this is the only factor which is common in all the 3 is 3. And how do we find the LCM? Let's multiply all of them. That is 2 into 2 into, I'll pick only this 3, then I will not pick this and this 3 here. So 2 into 2 into 3 into 5 into 7. Right? So that is equal to 2 into 2 into 3 into, so this is 4, 4 3s are 12, 12 into 5 into 7, or we have 60, that is 420 is your LCM. Then let's do the second part. Now I can clearly see that all of them are already prime and they are co-prime among themselves. Co-prime means that they have no factor in common other than 1, which is HCF will be just 1. And what will be the LCM? It will be product of 17 into 23 into 29. That's a big product. Huh? That is equals to 11339. Let's move on to the third one now. 8. Now 8 can be written as 2 into 2 into 2. Then 9 can be written as 3 into 3. And 25 can be written as 5 into 5. You can take 1 as well. Now again, the only common factor here is 1. So HCF will be 1. And what will be LCM? It will be, since they are co-prime among themselves, 8 into 9 into 25. Right? So it will be 1800. Next question. Question number 4 now. HCF is given to you and the two numbers are also given to you. You have to find the LCM. Now we will use the property that we have learned, that HCF multiplied by LCM is equals to the product of two numbers. We even verified it in the earlier questions. So let's just put the values. HCF is given to us 9. LCM is that what we have to find. And product of the two numbers will be 306 into 657. So what will be the LCM? 306 into 657 divided by 9. Now it's simple calculations now. So if I start dividing 3 threes are and 3 102 and then 3 threes are and 4s are, and 34 into 657, when you multiply you will get 22338. So this is the required LCM of 306 and 657. Next question. Check whether 6 raised to power n can end with the digit 0 for any natural number n. Now here we need to understand this first, that a number will end with 0 if it is divisible by 10, right? A number should be divisible by 10. That means if I prime factorize 10 also further, the number should be divisible by 2 and 5, right? So if I prime factorize 6 raised to power n, I'll get 2 into 3 raised to the power n only. Because if n is 2, that means there are 2 2s and 2 3s, right? If n can be any big number, but the whatever that number is expressed, it will only be product of either 2s or 3s. Only their count will differ, right? That means 5 is not at all a factor here. 5 is not a factor of 6 raised to the power n, right? Therefore, 10 is also not a factor of 6 raised to the power n. And therefore, thus, we can say that 6 raised to power n cannot end in 0. Now, question number 6. Explain why there is a given expression of 7 into 11 into 13 plus 13. And the other one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. They are composite numbers. To prove composite, you just have to prove that there is a factor. Now, the number of terms here are separated by plus and minus always. So, there are only two terms here. One is presented as 7 into 11 into 13 and the other term is plus 13. There are only two terms here. So if I take 13 common out of it, so first term it will be 7 into 11 and the next one will be plus 11. You can simplify the bracket if you want to, right? So 13 into 77 plus 1, that is 78. But even if you do not simplify it, you have already proven here that 13 divides this expression. That means 13 is a factor of that expression. So since you have written that means this implies 13 is a factor, right? And if 13 is a factor, the given expression is composite. Let's look at the second one. Now this is one term and this is the second term. The terms are always separated by plus and minus signs. So I can take 5 common here. If I take 5 common, it is 7 into 6 into 4 into 3 into 2 into 1 plus 1. You may simplify the bracket if you want, but even if you do not simplify it, you've already proven that 5 is a factor. If 5 is a factor of this expression, that means the given expression is composite. Done. Let's move to the last question. Question number 7 now, last question of the exercise, where there is Sonia who takes 18 minutes to complete one round and there is Ravi who takes 12 minutes to complete the round. The question is, if they start together at the same point, same time, same direction, when will they meet again on the starting point? So first, if I look at Sonia, when will she come on the starting point? First at 0 minutes, then 18 minutes, then 36 minutes and the multiples of 18. Similarly, if we look at Ravi, he will start at 0 minute, then He will be there in the starting point at 12 minutes, then 24 minutes, then 36 minutes. So multiples of 12. So we only have to find the LCM, the least common multiple. It is then when both of them will be at the starting point. So if I find LCM of 12 and 18, you can find by prime factorization also. So I am dividing it by 3 4s and 6s and 2 2s and 3s, right? So 2 and 3 are co-prime. So you can find the LCM by 3 into 2 into 2 into 3, right? So that is 6 2s are 12, 36 minutes. That means at the after 36 minutes they will be together in the starting point. The difference is Ravi is 12 3s. He has completed 3 rounds, and Sonia, who takes 18 minutes, has completed 2 rounds. But at the 36th minute they both will be together there. Now, link for the second exercise is given in the description box. Please go check it. If you like it, please share, subscribe, and press the bell.